Hello everyone, welcome to Global Hebrew Pass Online Meetup. I'm Maria Zakrudaev, I'm moderating those sessions. Usually our sessions are in Hebrew with some exceptions. Today we have as the speaker Rasmus Reinholdt, so this session will be in English, and he will be talking about building a real-time ETL solution using BIML and SSIS. And we want to make this session interactive. If you will not ask questions, then the speaker feels that he's talking to himself. So please press raise hand button and talk, or you can just write questions in the question tab. We really appreciate this, and this what makes those meetups differ from the regular, watching regular recording, because it should be some activity. This session is being recorded. You will get an email tomorrow with the link to session materials and to link to recording in a YouTube channel. Using this moment, I want to promote our YouTube channel. There are many great sessions, and a lot more are coming, some in English, some in Hebrew. There is one very interesting session on stream sets, which is SSIS alternative. In an email you will get after this webinar, you will get the link to our YouTube channel. Please go and watch all those awesome sessions. That's it. We're good to go. All right, Rasmus, we are listening.
Great. Yeah. Well, hello and welcome everybody. As Maria said, my name is Rasmus Reinholdt. Danish. So yeah, this session is going to be in English. So a few words about me, and as Maria also mentioned, please just jump in with questions along the line or at the end, whatever you prefer. I'll try and cover as much as I can, but I might not cover exactly the questions that you have, so please just raise your hand or type in your question. I have worked with BI and SQL Server for my entire professional life. I've done mainly ETL and relational data warehousing. I am currently employed as the data warehouse architect at UNOPS, part of the United Nations. And those are my contact details if you want to, if you some questions or anything comes up afterwards, and you feel free to contact me and ask the question. I'll be happy to help. So this session for the next hour or so will be about BIML. It will be about SSIS and about integrating it all to create the most real-time ETL that we can do. So it's going to bring you what's to gain from going meter-driven. It's going to show you the possibilities, and hopefully will give you something to think about. It's not a deep dive. We're going pretty fast about this and only just scraping the surface. And so it's definitely not a 1, 2, 3. Now you're ready for go and do some BIML. It will show you what BIML can do. It will show you how easy it is to get started, and I will give you some places to go for further information. And yeah, give it all a try afterwards. So we're going to look a bit into real-time ETL. Going to go meter-driven after that. I'll take you through the tools, take you through what is a metadata, and we'll look at a case story of building a new real-time data warehouse. So why are we even going to talk about real-time ETL? Most of you is probably loading your data warehouse once a day at nighttime. That was at least how I did it for many, many, many years. Nowadays, things tend to happen a lot faster than they did just 5 or 10 years ago. So yesterday's news is no longer interesting to most people. The head of sales want to see the big order that just came in. Inventory management want to see what that order did to the inventory, and so on and so forth. Also, nightly load windows might or might not be present. In my current job, we do not have a nightly load window. It's if you look at the globe in total, then from midnight till 2 a.m. is the only 2 hours a day when nobody is actually working, or at least not working hours anywhere in the world. And those 2 hours would not be enough for what we usually do as a nightly load. So a new strategy is needed, something that will load in much smaller batches and much more frequently. So that is what real-time ETL is about. It's about loading small batches of data and doing that more often than we would have done previously. Move as little data as possible. Move the data with as few dependencies as possible. Usually the load strategy would be something like load your staging area. Then we'll load the dimension tables, then the fact tables, and then maybe even burn a cube on top of that. That takes time. Every step of that process will take time. So move the data with as few dependencies as possible means trying to do as many of these operations in parallel. And then, of course, we need to move the data as fast as possible. Things need to be as optimized as at all possible. The screenshot at the right side of the screen here is my master package, if I so may say. It's the one that controls the actual running. Starts out by check whether or not we should even run. And if running should be done, then it will run what is called run staging download, and then go on afterwards to run SSIS intermediate. If the variable says that we should not run, it will go to the box that says wait 5 minutes, and yeah, it's going to wait there for 5 minutes, and then it will loop. This is a loop, so whenever it finishes, it just starts all over. So this one here, coming to the end, starts all over again. Coming to the end, it starts all over again. That means that the amount of data that we need to move will only be the part that has changed since the last run and this run here. So let's have a look at how this is done. So the main keyword here is loading as little data as at all possible. SQL Server comes with some very nice built-in tools for doing that. One is change tracking. The other one is change data capture. Change data capture will work even off an Oracle source. If you have such a one, you'll then just need to use the built-in SSIS component for doing that. With the just released SQL Server 2016 SOS Pack 1, change data capture became available in standard edition as well. Otherwise, if you're on a previous edition, change data capture will be an enterprise feature, whereas change tracking has, since its introduction, been a standard edition feature as well. So in order to use change tracking, we need to activate it at the database, and that's basically just like this. Set change tracking on, specify your retention. That means for how long are we going to keep that change data, and if it should auto clean up, or if you want to run the cleanup job yourself. Then you're going further on and you enable change tracking at the actual table level. And as you can see, well, it's at least hindered track columns updated. In this case here, I have that flag set to off, but that means you can actually activate this even for just one or more columns and not the entire table. So if we're going to run this here, it's going to start on by setting change tracking on at the database level, being AdventureWorks 2012, and then enable it on these two tables. So let's try and do that. And as you can see, these are the two tables that are currently enabled for change tracking. If we're going to have a look at this query here, it's going to give us all the data that are in those tables, and it's going to say when was the last time this data was updated. There's the synchronization version. It has the change operation, which in this case here is D for delete. U for update, and I for insert. So that's cool. We got 60 rows. And if we're going to say that, okay, now we have synchronization version or LSN 2200, we have already loaded that to our data warehouse. So give me everything that has come in since since LSN 2200. Well, that's a whole lot of nothing. So in this case here, SQL Server is going to tell us which data has changed, and it's tracking both updates, inserts, and deletes. So if we are going to make a bit of noise in this database, this is just a store product that generates 20 updates, 20 inserts, 20 deletes. So that was going to take a second. So we're going to rerun this one here. You'll see we once again have 60 rows. Those 20 updates, 20 deletes, and 20 inserts. And now with the new LSN. So going through and loading our data in this way here, it means we'll always only load that small amount of data that has changed since the last time that this system ran. So in that way, we do not need to load the entire tables over and over again, and we'll have a flag telling us what to do with this data. So this here could be used for a merge statement, for the deletes, the updates, and the inserts, in order to always keeping our staging area up to date. We could then reuse that same flag and that same LSN version to further push this data into our fact tables and our dimensions, and in that way we would know what to update, insert, and delete all the way through our data warehouse. So this one here is a script where you can see it's not that it does anything really out of the ordinary. It's like 20 lines here. And much of it is given to us just from the built-in functions like change tracking current version. And we have this here function called change table, where you specify which table you want to have and what is the version that you currently have. So it will give you whatever change has happened since that one. There are all ways of doing this. You could build a store procedure that would do that same thing. In this case here, sorry, let's just be in the right database. That would happen to help. This one here gives us everything that has happened. 1660 was the last version that this one here was saved with. So yeah, it will tell us that we have now something happened in LSN 2300. So in this way here, you could have a store procedure in the database for each of the tables that you're loading, and then you just query that, and it will return you the data. This one here is meant to be used with integration services, so it keeps the, it has a table variable at the top of it to be able to use a store procedure in integration services as the source. So that's good and fine. Now we have loaded our staging area, and we have loaded just a tiny bit of data, only the data that we're actually interested in, that is the data that has changed, insert, updated, and deleted since the last run. So let's go and have a look at what we can do with that. Where did my... Just 1 second, I just need to reopen this one here. It seems to have crashed. Oh no, stop there, sorry. 2 ways of loading this here. I have 2 packages here, one for a dimension, dim customer, and one for the fact, called fact sales. So when we have that data loaded to our staging area using the change data capture, we want to load the same way to our dimension, which means we're just going to load whatever have changed. To do that, we start out by creating a shadow table, which we're going to save all the changed values into. That's just a short procedure that basically does a select top 0 into another table. Then we'll load the dimension, source, which is just the staging area, select whatever. Then we'll check on the business key to see if that value is already in the dimension that we have. If it is, we'll output the ID of that one, our surrogate key. I'll tell you why in a second. So if we got a match on that, that means that we know this row. We have it already in our dimension. So we're going to put that into our shadow table, which is here called ETL customer instead of the dimension, which is dim.customer. If we did not have any match in this one here, it means it's a new row. So we'll just insert it directly into the dim customer. Dim customer has a unique index on the business key, which means that if try to insert multiple rows with the same value, this will fail and it will be redirected down to our shadow table. Whenever that's done, we run a merge statement. This is a store procedure that generates a generic merge statement. So it's just a dynamic SQL to make a merge statement of the two tables based on the primary key. The code for that one is on my blog, which was on the first slide. And then we clean up the shadow table again. So this means that we'll always only do delta into the dimension, updating the values that has changed using a merge statement much faster than doing it in integration services, and adding the dimension that are new, the new values to the dimension directly instead of having to check for them and then merge it afterwards. So we are doing this in the fastest possible way. Going, or at least referring back to the slides, running stuff in parallel. Usually we used to load the staging, then we loaded the dimension, then the facts. We will of course need to keep loading the staging area first. Doing that using change tracking or change data capture, which is in concept the same thing, means that will be tremendously fast and we'll be able to do so in a matter of seconds, of course, depending on how often you load and how much transactions are coming into the system. Doing that, we will then need to run the dimensions and the facts in parallel, or at least that will be faster than doing it consecutive. So in order to do that, we will here have the source statement for the fact, any given calculations that might be needed. We'll then look up the customer. This here is basically the same thing as I guess most people are doing. Looking into the dimension for the customer and the business key, returning the surrogate key. If there are no match, it will be a redirect rules to no match output. So now comes a bit the tricky thing here, is that the no match goes to another lookup. That other lookup has a modified SQL statement that points to a stored procedure. We're going to take a look at that stored procedure. This looks basically like that. It's only a few lines of code here with some comments on top. It's at least the first time I have seen it presented was by Thomas Kaiser. I don't know for sure if it was his work or it comes from somewhere else, but that's where I have it from. So what it does is that it checks to see, first of all, checking to see if the values here has been added already. Sales territory business key equal to lookup key. Remember the dimensions and the facts are running in parallel, so it might be that the value has been added after the lookup container was populated. But if we don't have a match here, we will just go in and we will then insert the value. Of course, we don't know from the fact all the attributes for the dimension, but we will know the business key and we'll be able to generate a surrogate key for that one. So in this way here, we'll add a new dimension value with just the business key and returning the surrogate key from scope identity. That goes back here to our lookup and is then used to populate the fact further down the line. So we'll not have these unknown, these -1 or whatever it is that you use for an unknown dimension value. Each dimension value always has its own corresponding surrogate key. So the next time that the dimension comes around, it might contain this recently added dimension that has been added by the fact package, and then this merge will then take care of adding all the rest of the attributes. So that's basically how we are able to do something as close to real-time ETL as possible, mainly by running things in parallel and by moving as little data as at all possible. So this here is kind of it's going to enable us to be able to run like a load every 10, 15, 30 minutes, depending on your system, of course, the amount of data generated and so on. And also it will, if you use that loop thing, it will just run whenever it has finished. So if a big chunk of data all of a sudden comes in, then yeah, that's going to take a bit of a while maybe to load, but then it will slightly chunk up and it will catch up and it will be running as fast as it can afterwards with as regular loads as possible. So continuing a bit, here, let's have a look at the meter-driven stuff. So now we are in a place where we are able to load our data warehouse every 15, 30 minutes. That's good, boss happy, but we need to be able to accommodate changes to our system, our source system. We need to be able to implement new requirements faster. That's the main two issues for doing meter-driven ETL. And then there's the third component that means that we need to be happy at work. Nobody likes dragging and dropping components in SSIS and Visual Studio or doing the same work over and over and over again. So that's what we want to do and what we want to accomplish by doing meter-driven ETL. We want to implement new stuff faster. We want to incorporate changes to our source systems faster, and we want to have fun doing it. So let's go and have a look at the meter-driven stuff. This is where our good friend BIML or BIML comes into place. BIML is short for Business Intelligence Markup Language, and as you'll see in a few seconds, it has some resemblance to HTML, which is where the acronyms kind of derive from. So BIML can be written in mainly 3 different tools. If you are on a SQL Server version prior to 2016, you will have either Bits Helper in Visual Studio or Mist. You can use Mist for any SQL Server version. Mist is the paid version. It's a paid tool created and made by Verigence, the author of BIML. If you're on 2016, there's another Visual Studio add-in that you can use. It's also free. It's called BIML Express. I'm going to use Mist for what we're going to do today and what I'm going to show you, mainly because it's a lot more visible than the free versions of the tools. But there's nothing of what I'm going to do today that you cannot do in the free versions as well. So let's start by creating an empty project. We'll give this one here a name. Let's just call this one here BIML So as you can see, we got ourselves a nice little design surface here, and that is what you get from buying Mist. That's the design surface, it's the look and the feel, and it's that you can see what's going on, plus a whole lot of other things that comes in the in this version, and it's not in the free version. But yeah, main thing is that you have a better look and feel, and you got a lot better debugging. So let's try and add some connection here. We are gonna go and get some data. So we got ourselves an OLDB connection here, which we can then open up. And we want to connect to a SQL server. I want to do that on the OLDB. And in my case, it's just the local host. And we want to use AdventureWorks 2012. Let's just continue doing that. Okay, and let's name this one here staging. So we now got ourselves a nice little connection manager here pointing to our database called staging. So BIML in all versions, both the free and the paid, can create database objects like the database itself, schemas and table, and integration projects and packages. Mist can take it a bit further and create multidimensional cubes as well. We're going to concentrate only on the tables and the packages today. So let's add a table, and we'll just jump right into the BIML script designer. So here we got a bare minimum of BIML. As you can see, it's an XML language. We got the namespace here, and then we got a few tags. Most of the tags will be in the format of tables, in plural, which is the placeholder for the individual, in this case, table. Likewise, we got packages, and between the packages end and start tag, we'll have all the individual packages. So in this case here, we got a table. That table has a name, and it got some analysis metadata, which we are not going to use today because that is Mist proprietary, and it's not available in the free versions. As you can see, I got two design windows here. I got the window where I am writing my code, and then I got the BIML the expanded preview down here. That's also a Mist version, and that's what makes the debugging so much easier. But let's jump right into it. I'm gonna cheat a little bit here, and I am gonna copy paste a bit of code here, and I will explain to you what it does. So this tells us that the code nuggets that we're going to introduce into the script will be in the language of C#. You can use C# or you can use VB, unless you have been coding VB for your entire life and find that one much easier to do. I recommend you using C# for that plain reason that 95% of all tutorials on the internet will be using C#. We need system.data. We need to be able to talk to our database. So this here is what makes BIML so powerful. That is that you can introduce C# into it. You could write all of this here by hand, and that would be nice and easy. You could write out your entire tables, you write out your packages, and doing all that one by one in XML, and that will also work, but that's not one we want to do. We want to be meta-driven. We want to rely on our data and some kind of metadata repository to be able to automate this whole thing. And that's why we need the C# introduced into the BIML. So we're going directly into the BIML script by passing BIML here. If you go to bimlscript.com, there will be much more information about how you're going to build the BIML, how you're going to write the XML for it, what are the tags, what are all those kind of stuff. As I said in the beginning, we're just scratching the surface here. I'm just showing you what are the possibilities. And this is, yeah, it takes a few hours to get into your fingers, but that is time that is pretty well spent when you realize how much faster you're going to work afterwards. So yeah, hang along and just follow and see what is it that we can do, what are the possibilities here, and then you can always explore this further on bimlscript.com. So let me just take this one here. Yeah, might as well just take it all. So this here is referencing the connection manager that we just created. Oh, I got this twice, sorry. So we're referencing our source connection, and then we're using one of numerous helper functions built into the BIML language. These are extensions to the C#. In this case here, we got a function called importDB. The importDB goes out to the connection it's pointing to. So in this case, it's pointing to our source, and then it reads that entire structure into its internal memory, and we are able to reference all the objects and recreate those objects and get data types, all of that imported directly into our BIML script without having to do much about it. So in this case here, we are doing an import DB on the source. The source, if you recall back, well, I recall the source for staging, so let's just rename this one here to staging. And that would use the AdventureWorks database and import that into memory. Then we got another function down here, table node.getBiml. In many numerous places within your BIML script, you'll be able to do the get BIML, and that is going to spit out the BIML for whatever context you call it in. As you can see, we got these tags here, less than, hashtag, and that is what tells the BIML compiler that what comes now is going to be interpreted as C# or VB, depending on which language you're specified. So going by this, let's try and put this one here to work. So now it's going out, it's reading the AdventureWorks database into memory, and it is spitting out the entire BIML for recreating that whole database. So as we give that a few seconds to work out in background, you can see at the bottom it says one files in queue, background parsing, table1.biml. So it's now reading out the AdventureWorks database schema, importing that into BIML. As you might have noticed already out here on the right side, under the tables, we now have 104 tables imported into our model. Under the previewed expanded BIML script, we now have all of those tables, all of that entire thing. Table name, DDL history, schema names, all the columns, all the keys, all the indexes, etc., etc. And the next one goes here, and so on and so forth. So nice and cool, we're now imported the entire structure for recreating AdventureWorks into our BIML. And we can right-click here and copy SQL script, get the DDL to actually create that table. So if you want to recreate your source system in your staging database, this is how you want to do it. You can also use it to integrate the tables, use those tables to get the metadata for your SSIS packages, table structures, and all those kind of things. This is probably going to crash now, since, yes, it is. Sorry about that. We'll just quickly recreate it. I'll reopen it, sorry. It's not able to connect to the license server. It's been having an issue with that today. just going from where we were. So we created our 104 tables, but yeah, that's good and probably useful in some context. But we might want to not get the entire database. You might want to say, well, you know, I only want whatever is in the sales schema. So we'll put that into the import DB, saying I only want what is in the sales schema, and I don't care about foreign keys. I don't care about column defaults. My data would have those defaults anyway, and I don't care about the views. So doing that, we now reduced our number of tables to 20, only the one in the sales schema. We can go a bit further than that. We can go ahead and then we can create ourselves another connection here pointing to our, I'll just get this in the right place, to our metadata. So we will just cheat a bit here and we'll reuse the one from staging. Otherwise we could just have created another one. And as you can see, this one here actually uses external data access get data table, and then it fires off a select statement. Select table name from table names. So if we were to try and look at that out here, so right now I don't have anything in the table names. So let's introduce a few values. We now got sales order detail and we got sales order header. So if we were to add that, you will now see that we got three table currency, sales order detail, sales order header. So depending on which database we're in. Yeah. So let's just put the table, recreate it, and just insert the two values. So we now only have these two. So if we were to update this, you can now see from over here that we only have these two tables, sales order detail, sales order header. So now we have the beginning of a metadata repository where we are actually able to control which data we are going to load. So going by this here, we could then continue. We can go down, we could add a package. So we're now moving on to integration services where we want to do an execute SQL task. We want to do a data flow, and that data flow should have an OLDB source and an OLDB destination. So we are building a rather simple staging package here that could, for instance, be a truncate staging table and then loading from the source to the destination. So now that I have the general layout, I could just go on and I can go in and check view in the BIML Script Designer. So here again, as I said, we got the packages, and then comes the individual package. I could just go down here where this package ends, and I could start typing in the next package. I can also do something else. I can, if you I will just copy these two here. Also be using a bit of scripting language for this one here. So in between here, then we're going to do a for each. As you can see, I have some nice intelligence. And then we're going to use root node tables. This is referencing basically the structure of our BIML project. The root node is the project itself, so in this case here that's BIML.mst, and then tables. So now I'm going to say that for each table in this, for each entry in root node, the tables, is assigning that to a variable I've just called table. So for each of this, we're going to do all of this here. So that means that for each table in the structure, we will create a package. I will just close that loop. So as you can see down here in the preview, and I have two packages. I got package 1. I got the next one. Of course, this here won't work, as it says it's lacking a connection name, and we got duplicate names on this one here. So we can easily take care of the duplicate names. We can just keep referencing our metadata. Now we're assigning it, so we need the equal sign. So in this case here, it's going to be like this, and then we will say that this here is table name. So if we were to do it like that, see now we have actually assigned the names of the tables to our packages. We can also mix and match all of this one here. So we want to say this one here should be import underscore like that. Then we would have that the names of our packages will become import underscore sales order detail, import underscore sales order header, etc. And we can keep building up our packages here. We can add a connection. So that one is we could keep going and going and build up our package, and in the end we would have a package that was capable of running. So the execute SQL task like here, we could give that a connection name, and you see it tells me, well, you only got one, so you can only choose staging, and we would be able to then keep working on this one here, telling it that this here should then be just and in between of this we might want to take in a direct input, and that would then be truncate table, and in here we can also reference our metadata. So that would be dbo dot, and then we will select, now comes a bit of code, so that will once more be table dot name. And I forgot the equal sign. So as you can see, we have now got truncate table, DBO sales order detail, truncate table, DBO sales order header. And like that, we could keep going and going, building up the data flow to actually reference the source get a select statement in there, and then we could use that to load into the destination. We can also keep going here. If we want to change a bit of our on our table structure and all that, we could, for instance, go in here and then we could say replace. Let's try and replace the IDs with business key, which is so we can know that what we are actually looking at are not the business keys and not the surrogate keys, for instance, whatever we want to do. So in this case here, what was previously named, or is what is on the source, named sales order ID would now be sales order BK for business key in our in our staging area. And we can keep on going here. We can also just say, well, that's cool, that is all the table that came in from our source system. So we might wanna add something to that. Just be in the right place. So we could add more columns out here. We could do a whole lot of things to it. Add keys, add indexes, all that kind of stuff we can also build along here in our BIML structure. So that if we were to look at something that's more or less complete, and sorry about the delay because it crashed previously. So in this case here, we have more or less the same structure. We got the staging tables. Same thing here, replace ID with business key. We're then adding columns for maintaining the CDC, giving it the package, giving it the LSN. As you can see, we're adding the keys back to it using the get BIML. And we can keep on going here. This one here and here takes and calculates the correct value for the default buffer size for the integration service from a view in the database, adds that as what is called an annotation. Annotation is kind of like a metadata placeholder that can then be used on the packages afterwards. So we're only just scratching the surface here of what is actually possible with the language, but hopefully you'll get an idea of the powerfulness of this and how much you can actually script out of this so that you don't need to be doing all that manual work that are usually the downside of working with BI. So all the things can be scripted, all the things can be in here and controlled by your metadata. So what is this metadata that I've been talking so much about? Well, metadata can be anything that you're envisioning it to. BIML allows you to hold your metadata in a SQL server. We saw a small kind of that with the table that hold the table names. That's metadata. You can also keep it in Excel, or you can do what I do. I use a hybrid, since this here is Excel connected to master data services and the SQL Server. Since 2008, our two master data services has been part of the Enterprise edition of SQL Server. So if you got Enterprise, you got this here for free already. So what is good about it? Well, it has many advantages. First, it keeps a version of your data. So if somebody changes something, you can always revert to what it was previously. So it's always a rollback from any mistakes that's happened. You can also use versioning to create different versions of your metadata. That means you can have one version for production, one for testing, one for development. Or if you're a consultant, you can have one version for your different customers. You can also build relations into it. In this case here, I got them in the different tabs. Down here, got data connections. pointing to my data connections. So you can see there's also validation. This one here won't validate. The only thing that's happening to it is, as it says, the attribute value length cannot be greater than the maximum size allowed. This value, this connection string here, is larger than the size I specified of it. That, of course, needs to be changed, but you get the idea. We can build all column validations into this tool. When then I go to configuring my staging tables, you see the same one as we were looking at before, I can here choose only the data connections that I have defined over here. When I need to start moving in and building my data mart, again, connection managers are only the ones available, but the source tables that I can choose as the source for my data mart is also only the ones that has been added as the staging tables over here. Table columns, again, I cannot add a column to a table I have not defined. Master data services also comes with staging tables wherein you can load directly the data. So instead of having to specify all of these here data types, all that manually, you can load that directly into the staging tables from sister tables of your staging area or wherever you want to take this from. So you got all this metadata loaded up and ready for free, and then you can start enriching it with what is your surrogate keys, whatever. In this case here, this two here will be looked up a surrogate key, one for customer and one in then sales territory. Also, I got an active flag. You can build this the way you want, and you can put in as much or as little data into it as you actually want to. Good thing about doing BIML is to start up slowly. Start by getting your staging area up and running. As you saw, we built a staging area here. It is somewhere in here, and that took, what, 5-10 minutes to get started, and that's basically all it takes. This year will be enough to have a simple staging area going. So 5-10 minutes from a blank piece of paper to something that would actually work in production. And you can build as many or few packages as you want. It's just a question of what you add to your metadata. If we had not limited this on here to only those two, we would have 104 tables and we would have 104 packages, one for each of the packages or one for each of the tables in our source system, ready to load into the staging area. Then when you feel more comfortable with BIML, when you feel more comfortable with the whole concepts and all that, and bear in mind, yeah, C# is what makes this here funny. It's what makes it capable of doing all the stuff that we really want to. But I'm not a developer. I'm actually a business guy of origin. I am an educator of the Copenhagen Business School with no formal programming training. But I've been able to build this just with what I have been able to pick up from Google and from taking a few of those free C# courses that are out there. So don't let the C# scare you. It's not really complex what you need. It's only what you can pick up from Google will be more than enough to take you there. So what I wanted to show you, this data mart here is actually bound to that metadata we were just looking at. So if we were to look at this one here in the BIML script, this one here has a lot of SQL at the top, and usually I put this here in a view. It's just here for the purpose of demo. But as you can see, and that is the only thing I want to show you by all the SQL here, is that, yeah, I'm a SQL guy and I'm a business guy. I'm not a C# guy, so I'll go really far to put as much of the logic as possible into something that I know, into my comfort zone, which is the SQL. So in this case here, I have most of the logic done within SQL, whereas I limit the C# part. Depending on your mileage, depending on where you're coming from and your knowledge, you might want to do this entirely different. So what I wanted to see here is that if I can find my derived column, do derived columns is in this case here 1. So let's try and see what is this here down here. As I said, is the expanded BIML. This is what becomes when the script up here runs. So let's see if we can find our, it's right here. As you can see, there are these two calculations, which are the two calculations that are in the derived columns here. So we want to change this one here. So line, well, first of all, we got a mistake. It should be line total, but an L. And then we want to increase our cells a bit here. So let's just multiply that one by 2. And we go to the master data and we publish this stuff. You can even annotate and tell why did we do this here. So doing that, going back in here, nothing changes. That's fine. But if we were to refresh the script and go down once more, trying to find our derived column task somewhere along the line, you can now see that the times 2 has been added and the total line without discount has got the L on it. So in that case, that's how you can build this here, and you can even help people working with this. You can see a change actually went through all the way down here to the mapping of the destinations. So yeah, we got these 2 down here, and if we were even to add one more, calling that one test, saying that's 3, and that is the same here. We'll just copy this one here in the interest of time, and then we will not have the 2 on that one anymore. And let's call this here for double line total without discount, for instance, and publish that. Let's see there. The member code is already in use. Well, I've been doing this demo a few times before. So we're doing the same thing, refreshing our BIML. For some reason we didn't get that line, but we got the change on the order quantity here. Might be due to those error that we got. But we are running on the last few minutes here. I hope that I have been able to show you what are the possibilities that we can do with BIML, how powerful the language is, how much you will be able to control. Super users could change and control these calculations for you, for how this is calculated. Offload that to someone that knows the stuff, that knows the business requirements, and have them being able to test out new calculations in your test system. And only, of course, when validated there, move to production. But all this here could be automated. You could build or have a colleague that is knowledgeable not enough about C# building off a workflow on the master data that would have that one called the BIML compiler, compiling the whole BIML project, and then deploying the SSIS IceBag to your test server for testing. So all of this could be automated. That's what it's all about. It's about offloading all the stuff that's not fun to do to someone else and automate the rest of it, so that we'll be able to be as flexible as possible and as responsive as possible, and have as much fun doing it as at all possible. So that kind of concludes this session for today, but I have shown you how to do a staging area with BIML and MIST. You can use MIST to build your staging area and to generate SSIS templates. MIST comes in a 2-week trial version. You should grab it and give it a try, give it a run. at least you can also use it to reverse engineer that packages you might already have and love and see how they look in BIML. That can only be done in MIST, but it can be done in the trial version of MIST as well. Use your metadata to control what is loaded. Do change data capture to minimize what you load. MDS is really powerful as a metadata repository, but what you end up using depends on what you like, tooling, etc. You can build your own. Data warehousing, yeah, I usually go for relational, mainly because that's where I come from, and it takes time to process a cube. Going half an hour back to when we were talking about real-time ETL, so you can see there's not really any time there to start processing cubes. If you really need a cube, do a rollout cube, but rollout takes too much time. So unless it's really needed by something in your business requirements, try to see if you can do it as a rollout. Take care of your dependencies. You can use your metadata to get your dependencies with what needs to be loaded before other stuff, all those kind of things. There's also SP depends and other system views in the database that will show you which tables depends on which other tables, where do you need to be careful when you're going to go and load stuff in parallel. Also, beware of locks and latches. You might want to use snapshot isolation level to get around this and to be sure that you can load those tables while people are actually reading from them. So what should you take with you home? Well, if you don't remember anything else from this hour, then please do remember that BIML is easy. It takes a few hours to learn the basics. BIMLscript.com has a really nice learning path set out with things, small courses that you go through, and it will bring you there. And otherwise, there are from time to time offered more lengthy courses around the globe teaching you BIML in a couple of days. BIML is all about build and reuse templates. It's all about metadata. It's all about having fun and only use your time and your energy on something that adds value, and let the scripts do all the repetitive work. Change data capture is one of the best things that ever happened to BI. It is what allows us to only load that data that has changed, and we don't really need to care about all the rest of it. And try to minimize the interdependency in your structure. That would allow you to run faster. So, sorry, that was from a previous presentation. That concludes this session for today. If there's any questions, please, let's have them. Otherwise, always welcome to contact me afterwards.
Does anyone have any questions? I see Ella said thank you. Thank you, Ella, for coming. I guess we just finish here. Yeah? Last chance, anyone? I guess not. So,
yes.
All right.
Please feel free to contact me afterwards on any of the contact channels listed on the first slide if questions come up afterwards.
Okay. Thanks, everyone. See you in the next meetings, and have a good evening. Bye.
Bye-bye.